Okay, so homework that's due Monday, I'm going to put up here on the board. You're going to have, after we're done with our notes today, you'll have time to work.
Ward, I have to leave in 5 minutes.
Okay, that's fine. Okay, just make sure you watch the video tonight. I'll make sure I post it after school today. I still got to do that. I didn't post it yesterday, so.
Mr. Ward.
I know. Page. Okay, so the pages that are due on Monday, page 434, 10 through, 105 through 111 odds. Make sure you're doing the odds. And then the other page is page 447,
Number 8.
7, 8,
Number 8.
10, 11,
Yeah, number 8, that's a trick.
15, 20,
The wall.
28 through 30, 37, 38, and 40.
Mr. Ward, I noticed that we have a book check coming up.
Yes. Now, again, this homework is due Monday. Make sure you're getting that done. That's Monday, May 7th. All right, now, other thing, if you didn't hear this, book check Wednesday. That's next Wednesday. If you're not going to be here, that's fine. I'll check it Tuesday if you're here. Okay. But
I keep my book at home.
well, you need to bring it because I need to see numbers and whatnot.
Well,
Okay.
I know it's mine.
I need to make sure the seniors are all taken care of before that last day so they're not scrambling to figure out where things are at. Because I know a lot of people leave their book here. Well, if somebody borrowed it, not my responsibility because I didn't tell you to leave it here. So, so I want to make sure everyone's book is accounted for so you know where it's at. So you're not charging $100 that last day of school and you have to pay him before you can leave. Okay. Other than that, you need notes, calculator, you need a practice guide out. Once we're done with this today, I'll let you have time where you can work on your homework. My goal today, since there's 18 questions on this test, we're going to do the first 9 today, 9 on Monday. I'm going to go through these pretty quick because I want to give you plenty of time today to work. And then if you have any questions, whatnot on that homework, you can ask. I think most people pretty much have it down. We spent so many days reviewing it. I think you should have enough examples. You know how to do them now. Okay, but let's walk through some. Let's walk through the actual math here. Okay.
So
we good?
The whole first page on clean.
Yeah, we're good. Yeah, I think, is that the first 9?
Well, I got 4 races in a row. Have you ever done that?
Okay, we're ready. Okay, headphones out. Headphones out. So, web. Headphones up.
I told my roommates to stop playing, so they just sat there.
Okay. Alright, here we go. Okay, first question. Okay, first question here. You need to approximate this number to the 3 decimal places. Okay, what you're gonna do is when you type this in your calculator, type in the number 3, you hit the little caret key, then type in 2.4. If you type in the caret, you can put parentheses, you can put anything you want there. I think on most calculators you don't need to.
I put pi to the power?
So, now, when you have this, just make sure you give me the decimals. Now, what I'm checking for is, do you know how to put powers? This problem could be as easy as this. I could have that problem sitting there. So, this problem is tricky because when you type it in your calculator, most people want to hit a caret key, then type in like the 2 behind it. On an E, you don't need the caret. It's already assumed that the next thing you're about to type is the power itself.
Why does it assume?
So it's just the way that most calculators work. So all you have to do is put a parenthesis behind it. And that's how usually most calculators work. I think mine, when you hit the little E key, it automatically throws the parenthesis there. It already knows you're going to put a power and it's waiting for the next number to be put. Okay? All right. Questions if you had like the natural number E. Now remember, you can actually estimate what that answer is because E is about 2.7-ish. That's what the number E is. And you're putting it to the power of 2. So you're going to be in that 4 to 9 range. Okay, somewhere in that ballpark. So you can kind of guesstimate where you're going to be.
Mr. Ward, why is E 2.7?
It's just the growth of numbers. So what they looked at is like over a select time, if population, like you have one person, that person has 2 others, that everyone's growing at a rate of about 2 and a little bit more.
Yeah.
It's just like this weird ratio of how people grade.
How do people come up with these numbers?
It's actually based on the formula that you guys did for your credit card, like the student loan one.
Yeah.
It's based on that formula, how they came up with E.
Show us the
It's a good
proof.
calculator. I know.
Yeah.
That's why I didn't.
All right. Hey, we're good with this. Okay, good luck at the blood draft. Hey, can you guys check if I have a time slot after school today? Are you guys able to check that? Go ask them. I think I'm signed up for like 3:40 today.
If you're not, you want me to
Taking
look
all
it
of
up?
his blood.
Mr. Ward, I heard you're donating a gallon of
You
blood
need a
today.
parent permission slip.
9 quarts.
Sad part is there probably no other workers on that. So,
And
alright.
why is that sad? That's a good thing. I mean,
So,
they're like donates it.
Alright.
How many times have you donated?
This year, I've donated once already, so,
Like 2018?
yeah, it was like back in January.
Where?
They had it at the Methodist church. I can do it like every 8 weeks, something like that.
Start donating every 8 weeks.
They usually like call me and do it.
Alright.
Alright, hey, question number 2. Okay, hey, question number 2. This is the one that a lot of people were asking, like, Ward, we haven't done anything like this.
Yes, we have.
We have. We've talked about it in class. There's a simple way I want you to do this problem. It says use a table. You don't need to. Here's what I want to see. I want to see a rough sketch of what these look like. Here's the thing. What is that number roughly?
3. 1 and a 3. 1 and a quarter.
1.3. Yeah, that's the numbers there.
Oh, it's 1/3. not
1 and a third. All right. Do you agree that that number is above the number 1?
I'm gonna say
Yes.
Okay. If this number that's in the parentheses is above 1, and you're putting it to a power, the graph always looks like this.
Oh yeah, I definitely could have.
Because it's growing. It's growing, right? If that number in there is less than 1, let's say it's half.
You didn't get an ace in right.
Let's say it's half. Well, this number is small, and when you make a small number with a power, it gets smaller and smaller. This is decaying. The growth rate is actually half-life. That's where the half comes from. So the idea is that your actual graph will look like this. That's the type of graph I want to see. Go a couple numbers in, see what it's going to roughly look like, and draw a rough sketch. I just want to see, do you understand what an exponential graph looks like
Yes,
versus a
Mr.
half-life graph, or something of power that's less than
I bet
1?
on the test they're gonna make
Okay.
a half-life.
So it could be either or.
We haven't done this before, have we?
Could it be both?
Yeah.
How about neither?
Do we actually have to draw it with another dollar amount?
We haven't done this before, have we?
Okay. What?
We haven't done this.
Yes.
Yeah?
First day.
Oh, yeah. I remember that.
Okay. We're good?
Yep.
Moving on. It should be easy. Like, don't overthink that problem. It says use a table if you don't know how to guesstimate it. All right. Moving on. Okay. Number 3.
I'm getting bullied over here, Ward.
Yeah, I'm getting annoyed already by people talking. I'm about to stop going through this. All right. So, on this problem, we have to go through exponential form. You have to change this problem back. And now, usually when I have this problem, I usually have it in one way. I usually write these problems like this. Like I put the log on the one side. You can like switch it using the symmetric property. But all you have to do is a little circle method and change it back to exponential. So this is your base. If they don't have something sitting there, it's a 10. If it's a natural log, that's an E. So, whatever this is, so mine is log base X, I think yours is a log base B. Okay? You're going to start with that, put it to this power, and set it equal to the item that's next to the base number. So, X to the Z equals Y, that's it. You don't even have to solve it. I just wanted you to write the exponential form for that problem. Okay, you're not solving it. I don't care that it's something to a power equals 27. I don't care that. Okay? I just want to know what the exponential problem should have been without the logarithm. If on your problem, if you actually write a log somewhere in that final answer, I automatically count it wrong. Because you have to get used to that. I'm going back to exponentials where I'm getting rid of logarithms. Okay, questions, comments about how that works. Remember, a logarithm actually means of the power. This is the power you should be putting on the base item. The base, that always that smaller item. Okay, does that make sense? Okay, moving on to number 4. This problem, we're taking this number and we're going to write it as a logarithm. So, okay, so on this problem, we're going to change this to a logarithm. So I'm just going to make up a problem. Let's go with w to the 5th equals 1040. I'm just making up numbers now. So, if you have this, you do the circle method and you can change it back to a logarithm. Log of base w of 1040 equals the power. Remember, a logarithm equals the power. So the power should be on the one side by itself. If there's no power sitting there, fine and dandy, it's a 1. That's just how it works, okay? Just kind of make sure that you understand what we're trying to get to. You're not solving, you're just writing it down as a logarithm. Okay, it could be a natural log if you have e's in there. I'm just trying to see, do you know how to do circle method correctly? Okay? Alright, we're good with number 4. Do you need something, Sid?
Yeah, I need to talk to you, but
I'm recording.
I might not be in
So,
class today.
Do you have your practice guide?
What?
You have your practice guide that I handed yesterday?
Yeah.
Okay, that's all we're doing, we're just reviewing that.
Oh, I was gonna talk to you about, when's the test next week?
Tuesday, Wednesday.
Okay, good.
Okay, good? Okay, hey, come back in later, sorry. Alright, number 5. We have to solve this one, okay? Alright, so on number 5, we have to solve this without a calculator. I should not see decimals or anything like that on these problems, okay? On these problems, you have to change the base. So what I normally do on these problems, I change this back to a log, or back to an exponential problem, but you don't have to, because here's how I think of this problem. You're just trying to figure out what power do you put on a 3 that makes this thing that's next to it. Yeah, you just think about like, okay, if it's a 3 and I'm putting it to a power to make the 1/9, the idea is that this number has to be negative because it's going to make a fraction, and to make 3 into a 9, it's a 2, so it's a -2. Now, how this also works, if you want to know, because I'm changing this back, right, putting x, 3 to the x equals the 1/9, right? So I can change this back to exponential. But this is called the change of, seriously, this one is terrible. The change of base formula is this, that you can move the 9 up to the top and put a -1 on it by moving this up to the top of the fraction. A 9 is the same thing as going 3 squared. And these powers can be multiplied together. That's a rule of exponents, that this can be 3 to the -2. And now you can start to see why the x has to be a -2. The powers have to be the same. That way, like if you're not really good at just guessing what the power has to be, you can actually change it. If it's a radical, if this is a radical in here, the power is going to be halves. Like small numbers, not whole numbers like 2s. Okay. So anytime they do radical. Just real quick, a 7th root on an item is written like this. Like a power that's a fraction is the same thing as a radical. So why this is useful is because maybe this is the item that they want you to figure out. Okay? They want you to figure out this. Well, the idea is that I'm going to change the item to be a 1/7, and then this item basically cancels out and you're left with the 1/7. You're figuring out what power you put on here. So, okay. Alright, now, the reason why is on these next few problems, they basically have you practice this, but with shortcuts. Like where certain logarithms and natural logs cancel out, and that's what I want to look at, okay? Alright, so, on this one, this is the natural log of, and I can move the e up and make it a -7 if you will. But natural log, this means log of base e of e to the -7. So since you have log of e, these can cancel each other out and you're left with that. Like that's just how you do that problem. Or you're trying to figure out what power do you put on this base, what power do you put on this base to make that thing? -7, that's the concept. Or you can drop the power up front and do the whole thing where you make 1s.
Okay, so what I did is I just took the ln and the e and I just like crossed them out as 1/7. Would you count that wrong?
That is technically wrong.
Technically? Okay.
Yeah, because it's got to be negative power. It's not a
Right,
fraction.
okay.
Fractions because there's no radicals in that one.
Right.
Okay, we're good with 6. This is the other concept on this particular problem. This is 10 with a log and the power of it. This log has a base of 10, so these things cancel each other out, and you're left with the item that's behind it. They cancel each other out. Right? Because if the base and the log that's in the power are the same. Now, if they're different powers, then you have to kind of think about how that works. So, if they're different, you have to change the bases so they turn out to be the same. Let's see, what's a good example of this? Could be something like this. Log base 5 of x. Let's say it's that, right? Do we agree that the bases are not the same? That's a 5, that's a 25.
Yeah.
You could make this 5 squared times log of 5 of x. You can make it, and then you can move this 2 up in the power, because logs, you can put powers back up in the logs if they're being multiplied together. So this could be log of 5x squared, and then now these have the same bases, so now they cancel out, you're left with x squared. That's a clever way to do it.
Okay, a lot easier.
So,
I like that, that's clever.
I'm shook.
Okay.
So would the final answer for 7 be the cube root of x?
Yeah.
Okay.
Okay, moving on.
Hey!
Bless you.
Bless you.
Bless you.
Alright, let's go to 8 and 9, and then we're done for today. Okay, so these were based on all these shortcuts on logarithms. It's testing like whether you know shortcuts to find exact answers without calculators. But these next ones, you have to solve the equation, like number 8. It's having you do these shortcuts, but like doing one inside another, like composite functions, where you're trying to like work your way inside out. Okay? So what you're trying to do is you're trying to figure out what power do you put on a 2 to make 32.
16.
What power do you put on a 2 to make 32?
Is it
5.
4?
5. 2 to the 5th power. So this whole thing
Just guessing.
is just the power you're putting on the 2, so it's the 5. That whole thing is a 5. Then the idea is that now on this outside you're going 5, log base 5 of 5. You're trying to figure out what power you put on this 5 to make this. 1, done. Move on to the next problem. The answer is 1, you move on. Like, you're going inside out. Okay, I'll probably have a problem very similar to that where you have to work your way inside out and see what your final answer is, so you can come up with it. Remember, logarithms mean power, so you're trying to figure out what power you put on the base that makes the number next to it, if it's possible. Okay, last problem of the day, number 9, because there's a total of 18, so I'm going to do this last one here. Okay, these, all you're doing is you're breaking these up, you're expanding them out as far as you can. If it's possible on these problems, let me scroll up so you can see this. If it's possible on this problem, I would like you to try to like simplify anything that you can. So maybe like in the middle of that problem when you expand it all out, maybe like one of the items you can actually evaluate it. Like you can actually find the number for that logarithm. Then you'd want to calculate that. Okay, now why I want to talk about this problem. For some reason, on this problem, people forget you can drop powers out. I have a lot of people always leaving the power in that object. So what I mean by this is a single logarithm, has base 8, but these are being divided, right?
Yep.
So you can separate these into their own logarithms, but you subtract them.
Yep.
Because that's how division works. You can separate using subtraction. Now, the problem is, that's not done. A lot of people always just stop there in the homework. This, yeah, you can evaluate this thing, because you're trying to figure out what power you can put on an 8 to make 64. It's just a number. And this thing you're not done because you haven't dropped the power out front. This, what's a radical as a power?
1/2.
So this is half on this thing, that's a half power. You can drop that out front of the log, just that one log that it's on. And then you can get to your final answer, I'll let you write that down. On Monday, we're going to continue with number 10 and move on. When we get to the problems where you have to like take an expanded problem and shrink it back, I think that is number 10. Where you have to take, like something where there's multiple logarithms or multiple like natural logs, and you're trying to change it back to the original item. People are really messing those up because they're trying to write everything with logarithms. You're going back to a single logarithm, not multiple logs. I had people writing logs, tops and bottoms, and they're all everywhere. Okay. Yeah. Okay, that's it for today. You'll have the rest of class day to kind of work on your homework. You can work on this practice guide. Test is Tuesday. Book check is Wednesday. Again, Wednesday is a spillover day if we need a second day. Thursday, Friday next week. We're doing math testing. Seniors, my select few seniors, you guys will just work in the back of the room on your practice guide for your semester.
I thought seniors had a first semester.
Yeah.